Okay, so I'm going to show you how to write Ionic equations. And before you can write Ionic equations, you must have some basic chemistry knowledge, which you'll be taught when you're done paper one. Three types of bonding: metallic, covalent, and ionic. Nature of acids and alkalis, basically they form ions in water. And some common ions that you should be aware of, like sodium ions and chloride ions and ammonium ions, etc. Once you've written the ions down, once you've written the ionic equation down, you need to check that everything should be correct. So if you put electrons in there, which is a common mistake, you will lose marks because that does not constitute an ionic equation. Charges on both sides of the equations must balance. So if you've got 2 plus on the left, you must also have 2 plus on the right. And the state symbols must always be the same as per the main equation they've given you to write the ionic equation of. And do not forget any balancing equation numbers that were in the main equation just gets moved down to the ionic equation. So it's important you have all these factors in there because this question is usually worth 3 marks in the main exam for GCSE and 2 marks for A level. And the common mistakes are that you forget the state symbols or you forget to balance it. Okay, so let's look at a simple example where magnesium solid reacts to give you magnesium chloride, and you can see that because it's ionic bonding, it's in aqueous form, and all metals are solid anyway, which you should know. So there's a change there. An ionic equation shows you any changes in the equation. So therefore, we must represent magnesium solid on the left as it was in the main equation, and magnesium ions on the left in aqueous form as it was in the main equation. So you can notice state symbols do not change, but it's reacted to give you that extra charge on the magnesium. If you apply the same principle, you got hydrogen gas on the left, which is covalent bonding, doesn't form ions, but it forms from two H plus ions in the acid because all acids are dissociating to form H plus ions. So they must also be included because you've got H plus ions in aqueous form where it turns into H2 in the gas. So therefore that is the full ionic equation, and a quick check if you look at it, 2 plus on the right is 2 plus on the left, and everything balances. So that's the okay. Let's look at another simple one that you see at GCSE and AS, which is a neutralization reaction. And just to give you some information right now, neutralization reaction must always produce water. For GCSE, for A level, 1 mole of water. Now, if we look at this, the main difference is you got aqueous, aqueous, liquid, aqueous. So your biggest change in the equation is water. So water has to form, must be in the main ionic equation. So, and if I put water in the main ionic equation, you think, okay, where can it come from on the left? Well, it must come from hydroxide ions because that's the only way you can get the water formed. And from the acid, it has to be the H plus because there's H in the water. So if you add the H plus in from the acid, and that's what forms the ionic equation. So OH minus ions plus the acid H plus ions will give you water in the main ionic equation. And there's one negative on the left, one negative, one positive on the left, which cancels out to give you no charge overall, which is why there's no charge on the right hand side. So always check the charge. Okay, so let's have a look at this equation where you got two solutions. You know it's two solutions because you got two aqueous on the left, and it's forming a solution and a solid, also known as a precipitation reaction, i.e. a solid is formed. Well, by just looking at the state symbols, you can see that there's a solid on the left, on the right, and there's no solid on the left, so that must form part of the ionic equation. So straight away you know that you're forming AgCl solid. So therefore, if you look on the left hand side, it can be formed from the Cl minus from sodium chloride solution, and it can also be formed from Ag plus from silver nitrate aqueous. Notice the state symbols do not change ever, so do not change any state symbols from the main equations in the ionic equations. Also note there's one minus on the left, which cancels with one plus on the left to give you no charge on the right. So the charge is also balanced, and there's no electrons, and the state symbols match, and there's nothing to balance also. Another common mistake that students forget is that on the left hand side, it doesn't matter what order you write the symbols, and it doesn't matter what you put on the right hand side of the symbols as well. So that equation can be written as Ag plus Cl minus gives you HCCl as well. So it doesn't matter which one, both are correct. Thank you. Okay, for my last example, we're using this very complicated example because there's a lot of things to think about. First, you got water. So water must come from the acid, as we've done before, and the carbon dioxide gas must come from the carbonate. So we know that because there's liquid and gas on the right, again looking at state symbols, and there's no liquid or gas on the left, that must form part of the Ionic equation. But the thing is, where does the carbon dioxide come from? It comes from the carbonate. Where does the water come from? Water comes from the acid, but the oxygen part comes from the carbonate. So the first information that you must be aware of is that the carbonate will turn into calcium ions. And the second information is that you must understand the H plus ions from the acid turns into the carbon dioxide and water by reacting with the carbonate ion. A bit more difficult example. So I'll repeat it one more time. The carbonate turns into the carbon dioxide and water by reacting with the H plus ions. A bit more hard. In this example, just remember carbonates will always give you carbon dioxide and water, always. Okay, there's nothing else that you will get. So that'll always form part of the Ionic equation, that carbonates will give you carbon dioxide and water. Looking at the charge, 2 plus ions here, 2 plus ions there, and it all balances. And that too obviously came from the main equation, and nothing changes from the main equation as well, the state symbols. Thank you very much for listening.